Hi guys, in this video we're going to learn about integration using substitution, and specifically we call it U-substitution. And we use U-substitution in integration whenever we cannot cleanly evaluate an integral. And the only way to really explain this is to do a couple of examples, and that's what we're going to do. So let's say I add the integral of 2x times x squared plus 1 cubed dx. Now, theoretically, I could distribute out x squared plus 1 and multiply it by itself 3 times, and then multiply that value by 2x. But it seems quite tedious to do that, and this is where U-substitution comes in, and this is a great example of a problem. So what I'm going to do is I'm going to let U equal the inner function, and we are going to call x squared plus 1 the inner function. So I'm going to let U equal x squared plus 1. Then I'm going to differentiate U with respect to x to get du dx equals 2x. And I am doing this because eventually what I want to do is solve for dx so I can replace my dx term and make it in terms of du. So when I solve for dx in here, I'll just move it over to get du equals 2x dx. And then this results in dx equals du over 2x. So now I have the integral of 2x, and this is really u cubed, because x squared plus 1 is u cubed, du over 2x. Now look at what we have. My 2x's cancel out, and I'm left with the integral of u cubed du. Now all I have to do is use the power rule. So this equals u to the 4th over 4 plus c. And now I can substitute back in my u as x squared plus 1. So this equals x squared plus 1 to the 4th over 4 plus c. And then, yeah, sure, I could write my final integral statement, which is going to be the integral of 2x times x squared plus 1 cubed dx is equal to this, x squared plus 1 raised to the 4th over 4 plus c. Another example is this, the integral of the square root of 3x plus 5 dx. I am going to let u equal my inner radical part, so I'm going to let u equal 3x plus 5. Then I'm going to differentiate u with respect to x to figure out what my dx is in terms of du. And I get du dx equals 3, which means du equals 3 dx, which means dx equals du over 3. So now I have the integral of root u du over 3. And I can take out that 1/3 by the constant rule, so this equals 1/3 integral, and I'm going to rewrite this as u to the 1/2 du, and that's so I can apply my power rule. So this equals 1/3 times u to the 1/2 plus 1, which is u to the 3/2 over 3/2 plus c. We're going to now include that plus c. You can do it at any time. And now this is going to be equal to, when I simplify that, u to the 3/2 over 3/2, it's going to become 2/9 u to the 3/2 plus c. And now this equals, now I have to sub back in my u, 2/9 times 3x plus 5 raised to the 3/2 plus c. And I can write my final statement that the integral of the square root of 3x plus 5 dx equals 2/9 times 3x plus 5 to the 3/2. And once again, we're using U-substitution because there's no convenient common integral that I know to solve this. And in essence, it can't be solved unless you use U-substitution. And there's one more example I want to do. It's going to be the integral of cos x times sine squared x dx. Okay. So, for this question, I am going to let u equal sine x. And that means I'll get du dx, the derivative of sine x, is cos x. So du equals cos x dx. And dx equals du over cos x. Then I can substitute everything back in. So I have cos x. Now, if u equals sine x, then u squared equals sine squared x. So I'm going to say u squared. And now I'm going to substitute my dx, du over cos x. Now, look at how nice this is. My cos x's are going to cancel out. And I'm left with the integral of u squared du, which equals u cubed over 3 plus c. And now all I have to do is substitute back in my u, which was sine x. So this equals sine cubed x over 3 plus c. And now I can write my final statement, the integral of cos x times sine squared x dx equals sine cubed x plus c. And here were the 3 example problems that we did. I'm going to have to zoom pretty far out. Here were the 3 problems we did, and now I'll scroll down. So we started all the way up here. We had 2x times x squared plus 1 cubed. We had the square root of 3x plus 5. And we finished off with my favorite, cos x times sine squared x dx. Thank you guys for watching, and in next video, we are going to go into more examples of integration using substitution and try and tackle harder problems.